Hello guys, let's solve number of ways of cutting a pizza today. This is definitely a pretty hard problem and it also happens to be the most frequently asked question on TikTok. So the problem says that we have a rectangular pizza of rows by columns containing either an A or a dot. A represents an apple and dot represents an empty cell, and we're also given an integer k. We need to cut the pizza into k pieces using k minus 1 cuts. So the rule says that for each cut, you need to first choose a direction, either a horizontal cut or a vertical cut, and you need to make sure that if you're doing a vertical cut, you need to give the left piece to a person, and if you're doing a horizontal cut, you need to give the top piece to a person. And we also need to make sure that each piece contains at least one apple, right? And and the goal of the problem is to basically uh, count the number of ways of cutting the pizza while making sure that each piece contains at least one apple, and we have to cut k pieces. So this is pretty important. So let's say this is your starting position, and we cannot start with a vertical cut here, right here. The reason being that, so once you do a vertical cut here, we give the entire left piece to a person, and then we are left only with this particular section of the pizza. And then now we need to choose a horizontal cut, and then we give this apple to a person, but the last piece now does not contain any apple. So that is not valid. We have to cut the pizza into k pieces using k minus 1 cuts, and we also need to make sure that each of the k pieces contains at least one apple. So for this example, these are the three possible ways you can actually cut the apple pizza. So let's see if about the constraints. So the rows and columns are within 50, which is not pretty high. This is again pretty good indication that a recursive approach is what we need to resort to. All right, let's dive in. All right, so we have another example here. So let's say we start at this position. So now we need to first choose a horizontal cut or a vertical cut. So if we say it's a vertical cut, we have like three options here. And let's say if it's a horizontal cut, we again have three options here. And then let's say we choose this particular cut. So we make a cut here, and we basically need to give this entire portion to some person, to a person. And then let's say and the remaining part of the pizza left is this part, and then now let's say we choose a horizontal cut. This means we need to give the top part to another person. So now our problem basically becomes just this grid alone, and then we repeat the process again and again. So I'm trying to explain this because we see why a recursive approach is needed here. So when we started with the initial problem, we need to basically recurse over all possible cuts. So we need to see if what happens if if this is the first cut, if this is the first cut, or this is the first cut, and similarly for all the horizontal cuts as well, right? Yeah. So next we need to think how do we decide where to make a cut? So we talked about how certain cuts are valid and certain cuts are invalid, right? So how do we decide that? Uh, so when we make a cut, we need to make sure that the piece that we're giving to a person contains at least one apple. So let's say this is the horizontal cut that we're making. We are at this point and this is the cut that we're making. So this piece, we see that it contains two apples, right? So we need to figure out a way in which we need to know immediately is the cut valid or not. Similarly, if you're making a vertical cut, and let's say this is the cut, so we have three apples in this cut, and so it's a valid cut. So again, we need to immediately know if this vertical cut is valid or not. So I'm stressing on the word immediately because we don't want to, let's say we are at this position and we don't want to now like run a for loop across this entire piece and count the number of apples and then say, okay, it's valid, or if it's invalid. We need to figure out a smart way in which we can find out this particular value in O of one time. So this is where this concept of prefix sum comes into play. So it's a pretty neat trick in which we can do some sort of pre-computation, and that will actually give us this value that we're looking for in constant time. Alright, now let's see how we actually go about filling this prefix sum array. So we'll be using a dynamic programming approach to fill starting from the bottom right to the top left. So this is the original array. It contains m rows and n columns. So let's initialize this prefix sum array with all zeros. It should contain m plus 1 rows and n plus 1 columns. Alright, so I filled in a few values. Now let's see how we actually go about computing this particular cell. So the goal is that each cell, let's say this is the cell that we are targeting, this cell should give the total number of apples in the entire grid, right? And similarly, if I'm at this cell, I want to, it should give the total number of apples in this particular grid. So if you're at cell, let's say I comma j, the value in that should represent the total number of apples in the rectangle starting from I comma j to the end of the matrix, right? So how do you go about computing that? So it's a pretty neat equation that you can do for that. So first we need to do is add the value on the right. Okay, so this value is going to give the sum of all apples in this particular grid, and then you go about adding the value in the bottom, and this is going to give again the sum of all apples in this particular grid. Now you notice how you actually counted this grid twice. So all you need to do is just subtract this particular value, right? So you first add this entire grid, and then you add this grid, and then you subtract this grid, and that is going to give the total number of apples in this entire grid. And of course you need to add 1 if this particular cell has an apple or not. So we see here that it actually has an apple, so you need to add 1 to it. So let's just formulate the equation. So let me call this as the right grid, and let me call this as the bottom grid, and let's call this as the bottom right grid. So the value at 1 of 1 is going to be the right grid plus the bottom grid minus the bottom right grid, right, plus the cell value. And this value is going to take the value 1 if it's an apple, and it's going to be 0 if it is a dot. So now I have completed this entire prefix sum array. So notice that this value 9 means that this entire grid contains 9 apples, and this, let's say this value 6, it means that this particular subgrid contains 6 apples, right? So now how do we go about deciding? So let's say now we are recursively iterating, and let's say we are at the top cell 0, 0. So for a particular row, we need to check, we're choosing a vertical cut, and we need to check if which of these cuts are actually possible. So all we need to do is just do 9 minus 6. So that's going to give us the total number of apples in this grid is 9. The total number of apples in this grid is 6, which means that 9 minus 6 is 3, and that represents the number of apples in the left portion that we're giving to a person. So you see how in constant time we can immediately know whether this cut is valid or not. The same thing can be expanded for the horizontal cut as well. You just need to do 9 minus 7, and that's going to give you how many apples are there in the top cut, right? So now that we have all the components for our code for our problem, let's start coding. All right, so let's first define the rows and columns. So that's going to be length of pizza comma length of pizza 0. Next we need to compute the let's start with computing the prefix sum array, where we're using a dynamic programming approach. So we need to first initialize this with all zeros. So I'm going to do that first. Range of calls plus 1. Remember how I said I want to add 1 extra row and 1 extra column, right? Rows plus 1. Okay, so now let's start filling up this prefix sum array from the bottom right to the top left. So it's going to start at rows minus 1 and end at 0, which means you need to say minus 1, and then another -1 representing that because you're iterating in the reverse order. And now for the columns, you do the same thing. Okay, and then first let's compute the current cell value. So that is basically gonna take a value 1 if the cell is an apple cell. So if it's an A, else it's gonna be 0. Okay, now we need to compute the value at I comma j. So how do we do that first? So let's first compute the right grid value. So that's going to be prefix sum, the same row but the next column, and then let's compute the bottom grid. So that's going to be the same column but the next row, right? And then let's compute the bottom right grid. So that's going to be the one column down and one row down. So it's prefix sum. Right, so the value at I is basically gonna be the right grid plus the bottom grid minus the bottom right grid plus the current cell value. All right, now let's just see if things are fine. Let's go ahead and print out our prefix array just to see if things look right. Oh yeah, so it's gonna be rows. Right. Yeah, so this is exactly the array that we wanted. Notice how the top left is 9, representing the total number of apples in the grid. So now let's move on to the recursive function. Alright, so let's start writing our recursive function. So it's going to take the current row, the current column, and the current value of k here. So you can think of why this makes sense, because each recursive state, each recursive function has like 3 values in that particular state: the current row, current column, and the value of k, the number of cuts you have remaining, right? And one more thing I'm going to do is I'm going to use memoization. So this is a technique where this is going to save you a lot of time. So all you do is basically say that if you have sort of seen this particular state before, then you can immediately return that, right? We don't want to keep computing different overlapping subproblems. So now let's define some base cases. The first one being if I'm in a state where there are absolutely no apples in the grid, that means I can immediately return 0. So this corresponds to the first case that I was talking about. So let's say we have this example, right? So we cannot make a vertical cut here. So in that case, when we are at k equal to 3, we'll be at this particular cell, and this cell has no apple. So that is an invalid method. So we should not count that way. Count that particular cut. Count that particular cut. So we return 0 immediately. And the next base case is you're out of all the cuts. That means you have found one valid way. You have exhausted all the cuts and you have found a valid way, so you return 1. All right. So now let's recurse. Let's say answer is 0. First we need to iterate over all the horizontal cuts. So that is basically going to be we start from 1 after the current row, and then we iterate over all the remaining rows. So now we need to ask the question, is a valid cut here possible or not? So that this is where the prefix sum comes into play. So we can compute that in O of 1 time by just doing this difference, the current row column minus the value at I. And this, if this particular value If this difference is greater than 0, that means that this horizontal cut is valid, meaning the top piece contains at least one apple. So we can now recurse. So when we recurse, we're going to pass in I, the current column, and we're going to subtract one cut. Okay, and we're going to repeat the same process for vertical cuts as well. So making sure there is at least one apple in the left piece. And then here in the recursive call, we need to check, we need to pass the current row, but we need to pass j, since we are iterating over all possible vertical cuts, right? And then finally, for the speed up, what we're doing is basically caching the answer, so that we can do with this. Okay, and that's about it. And then finally we return, oh, of course you have to return the answer here. So the recursive function is done. So all we need to do is just call recurse with 0, 0, and the number of cuts that's available to you is k minus 1. So yep, this should give you the correct answer. Yep, looks right. Let's submit it. So there was a mistake here. Alright, okay. So this mistake is just because they want you to, since a value can be very high, they want you to return the answer modulo this value. So in 10 power 9 plus 7. Let's do a quick check. Okay, missed the brackets. Yeah, looks right, and this should pass. Awesome. So this was clearly a pretty hard problem. We had a 2D DP matrix to fill first. Sorry, yeah, this is the 2D DP matrix that we filled first, followed by a recursive function with memoization. So this single problem did actually cover a lot of concepts. Alright, thank you guys for watching.